Hello world, it's Suraj, and today we're going to build a fraud detection API using machine learning. I say API because I think APIs are one of the fastest and easiest ways to actually make money with machine learning. If you don't know, an API is an online service that other services or stores or web apps or mobile apps can use to do some sort of task. And so what we can do is we can build a server, put machine learning on that server, and serve it to other users using endpoints. These are REST endpoints, and I'll talk about what that means. What you're seeing here is me using a tool called Postman to test my own endpoint. As you can see, it's running on localhost at this endpoint right here, and the parameter that I sent it was some credit card transaction. Right now there's only one feature, which is, or two features, sorry, which is one of them is a hidden variable. It could be the time the user spent browsing on the website, it could be their location, whatever it is. I've compressed it. To be more technical, I've reduced the dimensionality using a technique called principal component analysis. Don't worry, we're not learning about dimensionality reduction just yet, but the point is that I gave it some new transaction and it returned this prediction ID, which is 0, which is not fraud. And I trained this using the Kaggle fraud detection data set that is readily available on the internet, and I want to show you how I did that. So first of all, fraud is only going to become more rampant in the coming years as everything moves online. So the need for security services are going to increase in importance. So people who get paid to do cybersecurity get paid a lot. For example, I know a guy who makes $1,200 an hour-ish just doing cybersecurity contract work. And I'm not just, pumping up that number, I'm serious. $1,200 an hour. That is more than mobile development. It's more than web development. So clearly cybersecurity, and by the way, for reference, he lives in San Francisco, so keep into consideration regional pricing. But that's still a lot of money, even for San Francisco. So something to consider as you look at this field. And so what I have here are two images of fraud detection and all the different ways that machine learning can be used for fraud detection. And what I want to do is help you understand how it's going to work programmatically. What you're seeing here is a decision tree where all of these features are less than or greater than points in this decision tree, where you just go down the graph. If it's a new transaction, it just checks at every node in that tree to see where it's going to go at the end. And at the very end, if it's greater than $20 and the countries that the card is used from is greater than 2, then it's 25% likely that it's not a fraud, or 25% likely that it is not fraudulent. So that's just one example. So of all the models that we can use, I think the best one for this, the one that I keep seeing for fraud detection, is logistic regression. Now, keep in mind that deep neural networks are generally better than logistic regression models given enough data. So we don't always have enough data, and to start off, I think logistic regression is a great model to start off with. And for reference, logistic regression, I have a great video on how that works. Just search logistic regression Suraj. It's super detailed, it goes into all the mathematical details, but we're not here for that. We're here to figure out how to make money with that, right? So this domain knowledge alone is not useful. How we use it to make money is useful. So let's take a look at this Kaggle data set right here. So it's a CSV file. It's basically like this Excel spreadsheet. And the great thing about Kaggle is we can see the data set, a preview of it right in the browser. We have a bunch of these features just called V1 all the way up to V28. V19, and we have no idea what those features are. But what they are in actuality are, time spent on a website, the country, the location, the IP address, all of these different features that have been hidden from us. And a lot of financial data sets do this because we don't want the person training a model to know about this sensitive user data, but that we can still learn from their data, right? Because it still has a unique signature that whatever compression algorithm we used for it spits out, basically. So there's that, and then there's the label, which is fraud, not fraud, which comes out as a binary label. So this technically is binary logistic regression. So that's the model that we're going to use. If you don't, go ahead and sign up for a Kaggle account. You won't regret it. All right, so go ahead and download that data set first of all. Good old credit card fraud data set. And the next thing we're going to do is we're going to find some pre-trained model on GitHub. Here's the thing. There are so many pre-trained models for these Kaggle datasets, and they're used for competitions, they're used for projects, they're used for hackathons, but rarely are they used to make money with. Why? Because it takes some work to set up a web app and set up a pretty visual interface and all these other things, but we can do that work, right? So let's do that work. So first of all, I found this great fraud detection. By the way, from now on, I'm going to link everything that I use in a separate module in each week called resources. Shout out to Ray for giving me that suggestion. He's the TA. So let me show you what I'm talking about here. This credit card fraud detection project is basically a notebook where this guy used the exact same data set that I'm talking about. He went through all of the steps of pre-processing the data, cleaning it, formatting it into a nice little table, splitting it up into training and testing data. You'll find as you do more and more machine learning that this kind of thing just keeps on happening. It's like, this is why AutoML is a thing now, right? It's automating that whole initial pipeline so we can just focus on what questions to ask and applying a data set to a specific use case. And so what we can do is we can just go to this GitHub repo, download the pre-trained model, and we'll build the API around the model to serve to users. So let's go ahead and download that as well. So now what we want to do is we want to build a Flask app. So let's go ahead and build a Flask app, all right? So Flask has some great documentation that we can use as a starting point for this, and we'll go right to their website and look at their instructions right there. So as always, minimal application with Flask is super simple. All we want to do is we want to say, we're going to create a new directory, Flask test, cd into it, Sublime, paste that in as a hello.py file. So now I can go to localhost, and there is my Flask app. Great. So that's a basic Flask app, and now what we're going to do is we're going to modify that Flask app to have this API for this pre-trained model. What we want to do is we want to say, okay, so what do we need here for any kind of basic data pre-processing? Well, we know we need a NumPy. We know we need to have JSON because we're going to be, that's the format that we're going to send the data in. System for any kind of read-write operations. We know we need pandas because we're going to import it as a data frame to modify the data. And then what machine learning library do we want to use? Well, the simplest machine learning library to use to start off with is scikit-learn. That doesn't mean it's the most accurate, it does mean it's the most simple to start off with. So that's what we're going to do to start off with. Later on, we can import TensorFlow or any of the various TensorFlow sub-libraries like Keras, etc. So PCA is going to help us perform dimensionality reduction, which we're not going to talk about the details of right now. Just know that dimensionality reduction will take a feature and it will reduce the dimensionality. What that means is sometimes data has hundreds of features and we can compress those down to one if we wanted to, or three, or five. We're reducing the dimensionality. What else do we want to do? Not import from. What else? Scikit-learn.preprocessing. We want to import standard scalar. What standard scalar is a way to normalize our data so it's all on the same scale. Sometimes, some data is on a scale of 0 to 10, and sometimes some data is on a scale of 0 to 5 million, and that can really skew our results, our predictions. So standard scalar normalization can help us prevent that from happening. Now, like I said, we want to use logistic regression, so we'll import logistic regression. All right, so that's pretty much it. Now, what I want to do is I want to say, well, where is that file? So let's assume that I've downloaded it. It's in that pre-trained model. It's in this same directory, and now I'll just call it trainmodel.save. That's the saved model file that we're going to serve to users via an API. Now, the great thing about Flask is we can define a bunch of routes, and routes are basically endpoints that we can query via the web, or our paid users can query via the web to access our service. And so the job we've done is we've trained a model on some data, and now we're going to serve it to users. So how do we do this? Well, first of all, let's go ahead and just get right to the route that we want to create. So first we're going to say app.route, and we'll call that route API/, it's our first version, so we'll call it v0, and that's it. We'll just call it API v0, and then I don't know. test. Let's just call it test for now. And what are the methods that we want to be able to access this API with? Well, we can say it's either a get method or a post method. The post method is when they request data from us. The get method is if they're trying to access it via the web, and maybe we can just show them some web page just as like this fail safe, like, hey, you're supposed to be doing post, but you know what, you did a get. Let me show you some nice little pretty HTML. All right, so we have our route, and now we're going to define our prediction. So here's what we do. We say, let's load up our model. And I think we actually need this library called joblib. Yeah, parallel computing. Yeah, joblib. So let's go back to this. So basically, loading up a model in real time for a user, especially at scale, can be very computationally expensive. It can lag the network. So we want to prevent that from happening. So there's a bunch of different techniques. There's a whole theory around this, around asynchronization and parallel computing. But just for now, let's use a library called joblib. Which is a part of scikit-learn. And once we have joblib, we'll use it to load up our model. So joblib is going to, in parallel, while the request is being made asynchronously, load up our file name that it's wherever it is on our disk. It could be on our disk, it could be on a server, but we already defined the name of it, so we now know where it is. And so the loading is happening without blocking the network call. And so now we can say, okay, so let's get the response from our model. So we're going to turn this into a string because we want to display a string to our user. And we'll say, okay, take that loaded model that we have, make a prediction with it. Thank you, scikit-learn, for that nice little pretty predict function. And then we want to say that we're going to make a prediction using, oh, you know what I didn't do? I forgot one thing, hold on. So I've got to actually take the request. So I'll call it vector. I'll call it whatever. Let's just call it like request. So the request is, no, that's already got a name. So it's going to be called vector. So the vector is, this is where pandas comes in. I'm going to put the request into a data frame. Now you might be thinking, well, what is the request? Let me tell you exactly what the request is. The request is going to be of the format. So I only had 2 features here, but ideally we need 29 features or so, which will fit the bill for what we want this to look like. It's like Vs1 through all the way up to here. It's basically like that. And that's what we want to show. That's what we want to feed it in the form of JSON, or that's what a user will feed it. Now we can play with that formatting and we can switch it up, but to start off with, let's just start with this. Now we have that part. We have loaded up the request, and now we can say predict using that input data. The vector is the input data that the user sent us, and we only want to make one prediction at a time, so we'll say the first element of this multiple object array, assuming it's multiple objects, we'll just start with 1, and that's our response. So this is the prediction line. And now that we have this prediction line, we'll say, okay, so the result is going to be, and now we create our result formatting that we're going to send back to the client so that they can use it. Now, if we were making a web app, then we would have this be sent back to an HTML page, but we're not making a web app, we're making an API. So we'll say, all right, so the ID is going, so we'll give it some unique ID. And honestly, we could just generate some ID, some random number generator, so everything is unique, but let's just call it 0 for now. And then we're gonna have our prediction, and this is the result. This is the machine learning right here. So we're gonna send it back as this JSON response. And that's the result. So we have, let me delete that. That is our result. And now that we have our result, we'll return that result in the form of JSON, so the JSONify. Did I ever import JSONify? Oh, sorry. import JSONify. We're going to return that. We're going to JSONify the result. And that's what we return for this. Yeah, and you know what? Let's just name this verify, not test. Okay, so that's basically our model right there. We might want to create some more. We might want to create some more functions, but that's a really simple first one. Let's test it out and see how it works. So in Postman, by the way, if you don't have Postman, let's just go through and install Postman together. Postman is great because it's an easy way to test out your own API very, very simply. So the Postman user conference. I mean, that's cool, I guess. We'll just download Postman. It's got a Windows version, it's got a Linux version, and once we have Postman, we will install it. And then, so I've already got it, so I'll just open it right now. So basically we can make requests using Postman and it's going to send us back a response. And we can say, okay, so the first key is going to be, some PCA encrypted or reduced, dimensionality reduced feature, 1.2 point, blah, 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 and then this is going to be called V15 or something, and then we have our value, and we just keep adding them just like that, and then we make a request. And after that, so it looks like that works. That works great on some random credit card function. Now, we want to make this a paid service, right? So how are we going to make this into a paid service? We have this API. We can put it on Heroku. We could put it on some web server, Google Cloud, Amazon, whichever one we want, right from the command line. But we also want to make it paid. So what we're going to do is we're going to add Stripe to it. So let's see, Stripe, Python. So Stripe is my go-to payment option. So what we can do is we can say da 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 da. What do we got here? Let's see their docs. Let's read the docs together. There we go. Import Stripe. And so what we can do is we can actually create another route right here. So we have a sign up route that we want to create called sign up. And so we'll have a web app component of our API, and we can say, all right, so this is going to be obviously a get method because the user is going to get it via the browser. And then sign up process. And so we can call this from some HTML file that we create. And inside of that, we create a charge using their data. So let's just say this is going to be request.amount. Hold on. Let's say it's going to be like this. Like we haven't even made the HTML, but I already know what it's going to look like. It's going to be like card data equals request.json. And let's just, for the sake of simplicity, let's just say card data. Yeah, I think that's fine. Card data. And then once we have the card data, then we'll say assume it has different properties like the amount, the currency, card data. We'll define all of this in HTML. Card data.us.currency, card data.customer. Card data.description. Card data.id. Okay. Yep. So whenever a user types in their card information, they hit submit. We could be doing that client side with Stripe's JavaScript snippet, which is in all my startup videos, but I want to do this from the back end because why not just do it all in Python? I mean, it doesn't really matter. You could do either or. And so once I have that, let me remove those brackets. We've created a charge, and it's going to return a charge ID. So we'll get back that charge ID. And then that charge ID is the customer's charge ID, which we will store on their user account. And once we store it on their user account, once they make a request, that's basically their API authentication key. And only if they have paid can they make this authentication key. So what that means is, we'll say, let's take the vector, the request.json that they sent. The request is also going to include their authentication key that they've made that we instruct them on how to do in our own documentation for our API. And we say if vector.id is, and we'll store that in our own database. We'll store in our database. So we'll have some kind of, we'll query our own database. If database.query vector.id is true, then do all this. So if the user has successfully signed up for our service, then perform all of this. Else, return, you must pay, you must pay, as a string. And we'll just JSONify that. You must pay first. Yeah. And then this goes in here. So kind of like that. Right? All right. And so what does our database look like? So let's go back to Firebase. I really need to make just a full-on tutorial of Firebase. Man, there's so many different components here. Like which one to start making tutorials of? I think with Firebase, Firebase just deserves its own video on. I'm going to do that in week 5. I'll make a Firebase tutorial in week 5. But just know that Firebase is my go-to for creating any kind of database backend. So traditionally you could just make your own SQL database and store everything there and maintain it. Or you could offload all of that maintenance to another service, and Firebase just works really well. And so they have a Python library, which is super awesome, called Firebase Python. And what we can do is we'll create a Firebase project, and then we'll say, create a new project, Firebase, continue. Not right now. Go. Creating. And so what's going to happen is we're going to query our own database. So the customer will sign up using some HTML page we'll make, just some checkout page. We get that card information. We then take that card information. We use Stripe to create a charge, and it's probably going to be a recurring charge because we love subscription fees when we're trying to make a sustainable income. We'll get some unique ID that tells us that this user has paid for our service. We'll then store that ID next to that user's username and password in our Firebase database. And then whenever that user makes a request to us, so they're probably a store owner or some kind of e-commerce store. Whenever from that store we're getting a API request to our service that says, hey, a customer just used a credit card on my website. Can you check if it's fraudulent or not? We can say, okay, and then we'll do that. But let's also, inside of that request, have your user authentication details, right? So in order to use our API, they have to have their user authentication details, which is basically going to come out to be a secret token. And then they'll send that data to us. We'll check that token via the Firebase database. So we'll query the database. We'll check if it's there. If it's there, then we'll return the response, whether or not it's fraudulent. And if they didn't pay, we say, you got to pay first. So that's kind of like the basic high level of how that workflow works. And I've created a new Firebase project, great. So we've got to add an authentication, we've got to add in the login, the sign up form, the bar, but I wanted to show you more high level of what this process, this workflow looks like on how you would structure it to make money. But all the details, I mean, there's so many Firebase tutorials out there. I'm still gonna make one, just not this week. What else we got here? There's our database. Create for this app. Create the database. In Europe. Our database is ready to go and we can query it straight from our web app. And I would just go on GitHub and find Flask Firebase. There we go. There we go. All right. So once we have our API key, we'll add that in, import the necessary Flask, auth. There we go. Nope. And then and then we get there. Login user and yeah, just like that. All right, where else were we? So this app works on Postman. What I want you to do is I want you to try out the basic REST app, the REST API. I've got the starter code for you in the resources folder for this week. Just figure out how to make a basic API. Everything else is kind of just extra. So I hope you found this video useful and I hope to see your homework by Sunday of this week.